Okay, now it's recording. Second, after each class, the notes with my written will be uploaded by 10 a.m. If I didn't do that, feel free to shoot me an email, okay? Just to remind me. Also, the last thing, before each class, I'm going to write a few key points of that class and post in Canvas. For example, let me share my screen. You can see what I uploaded today for today's class. Okay, so this is our Canvas. Click on module, you see what we have for week 1, week 2, week 3. So according to the syllabus, we are doing section 7.4 today. And today is February the 3rd. If you click on it, you see the keynotes of today's class. We're going to have the general definitions of trig functions and have a review of some basic quadratic properties. Third, we will discuss how the signs of trigonometrical functions change. Fourth, find the exact value of any angle. Okay, that's the 4 main points of today's class. Okay, any questions so far? Okay, so let's continue to do every point I mentioned here. Let me share my document camera. Okay, this is my document camera. The first main point today is we are going to do some basic extension of how trigonometric function is defined. We actually mentioned this in the previous class. However, let's do it again. Just make sure everybody is on the same pace. For any point, really any point, A comma B with coordinates A comma B on the coordinates, how do we define the angle which is generated by connecting the origin and this point with the x-axis? Let's say this is theta. Okay, imagine this segment has a length r. So you can draw a vertical line from here to below. And since the coordinates for this point is a comma b, so this side must be b, this side must be a. The 6 trigonometric functions. 6 times a not, but please just remember 3 of them. First is sine theta. Sine theta is defined to be the opposite side divided by the hypotenuse, b over r. Cosine theta, the adjacent side divided by r. Okay, that's 2 basic stuff. Once you are done with those 2, let's see what is tangent theta. Tangent theta is b divided by a, the opposite divided by the adjacent. So the remaining 3 are just derived from those 3 trigonometric functions. Let me show you. CSC, cosecant theta. Sorry, can you please mute yourself? Okay, who is talking? Okay, great. Let's continue. This is a review what we have done in the previous class, and we write it more clearly. Cosecant theta is 1 over sine theta. Okay, whatever value you got here, just 1 over it, you get a cosecant. Secant theta is 1 over cosine theta. Whatever you have here, you got to just 1 over it. So easy way to memorize that is, if you don't know what it is, just remember C is the opposite of S. Okay, C and S, they are opposite of each other. You see, cosecant begins with C, so it's 1 over S. Secant is S. It begins with S, so it is 1 over C, cosine. Okay. This is how I memorize it. C is always the opposite of S. Then lastly, cotangent. Cotangent is 1 over tangent, okay? So for every trigonometric function you have here, 1 over that, you create another trigonometric functions. So it's more important to just memorize those 3, then you can figure out the rest of it. Okay, any questions so far? Okay, so let's continue. We did our first key point today's class already. So let's see how we work on the lecture notes. These are our lecture notes. And for reference, I put this paper right to the left of it. In what quadrant of the point on the terminal side of the angle will be? So as we all know, the coordinates can divide the whole surface, whole area into 4 quadrants. We always counting counterclockwise. This is first, this second, third, fourth quadrant. Okay, so which quadrant it will be? So let's just find the point.
Would that be the 4th quadrant?
You are right, correct. So why it is on the fourth? Let's find it. The x value is positive. So which means the x coordinate is somewhere here. So it is either on this side or this side. But you see y coordinate is -5, so it must be on this side. Okay, y coordinate is 5. So it is in the 4th quadrant. So if we connect the origin with this point, you see a line shooting out into the 4th quadrant. Okay, cool. Any questions so far? This is just a specific example how we find a point. In general, this goes to our second key point of the canvas. We should figure out a general property of the quadrants. And the general properties are pretty straightforward. Everything on this side has a x greater than 0. Everything on this side, whether it is on this side or this side, has a y greater than 0. Here, it is y smaller than 0. Here, it is also y smaller than 0. Here is y smaller than 0. On this side is x smaller than 0. Okay? So whenever you find a point, you just put the point accordingly. Whether x greater than 0, you put on this side. If y is negative, we put on this side. You see, the only place you can place a point is here. Okay? Here and here. So the only point which is this area. Okay? So that's the general properties of the quadrants. Also kind of review. Does anyone has any question how we find a point on the quadrant? Okay, cool. So let's continue. In which of the following angles, if they are in the standard position? Which quadrant? How do you figure out that? Again, as we mentioned in the previous class, if you start from origin and move 180 degrees, you go the reverse direction, okay? So let's see, we see 225 is 180 plus 45, which means if you have already went 180 degrees to here, you should also move another 45 degrees more. Okay, so you would reach to this side, and the angle looks like this. So which quadrant is this angle? Can anyone tell me?
Quadrant 3.
Very good. Cool. How about negative 225? Again, negative sign means clockwise. Clockwise, moving your angle. So let's draw the coordinates again. If you move from here to here, you move 180 degrees. Okay. However, you have 225 here. 2 times 5 is 180 plus 45. Traveling the clockwise 180 is not enough. You should go another 45 degrees more, which goes to here. Okay. 180 from here to here, then 45 degrees more. So your final answer should look like this. So which quadrant it is?
That one's the second quadrant.
Very good. Second quadrant. So this is second quadrant. This is third quadrant. That's it. Okay. Now, again, we are increasing the level of difficulty. In what quadrant will be the theta be? We're not taught with the angle, we just taught the sign of the angle. So, what should we do in this case? Again, if you do not know how to start, Everything goes back to the basic definition. Okay, everything goes back to the basic definition. Okay, so this is a paper I wrote at the beginning of class. For any point, we do not know the value, and we calculated the trigonometry functions in this way. Okay, notice that R is always positive. The length for the hypotenuse is always positive. The only thing can be tend to be negative is either A or B. Okay, so the question told us sin theta is smaller than 0. So which means this guy is smaller than 0. However, I told you the length of hypotenuse is always positive. So the only thing which can affect the sign of the trigonometry function is this part B. Okay, we told this is smaller than 0. Okay, B over R is smaller than 0, and R is always greater than 0. So this implies B must smaller than 0. Do you guys agree or disagree with this?
Agree with it.
Cool. Similarly, we know the cosine theta A over R is greater than 0. However, R is always greater than 0. So the only thing which matters is A, which implies A is greater than 0. So now you see, go back to this first question. You know the x coordinate is greater than 0, y coordinate is smaller than 0. Look, x coordinate greater than 0, it must be on this side, either this quadrant or this quadrant. Y smaller than 0 is on here, either here or here. So the only thing which the point can be placed is in the fourth quadrant because it satisfies the two conditions. Okay? So the answer is fourth quadrant. Okay. Any question on this point? Okay. So we can just write a fourth quadrant here. And we don't need this map anymore because we do not draw a line as we did before. We just use algebra to figure out the signs of the x and y coordinates. So what we just talked is third main point. Let me share the screen again. So this is the third main point of today's class, signs of the trigonometric functions. Okay, how it is related with the x and the y coordinates. This is our first. Yes, this is our first example, and we are going to do a few more examples to see how exactly it works out. Okay, any question before we continue to the next one? Okay, cool. So again, we increase the level of difficulty here. In this question, we are not directly taught with sine or cosine. We're taught with secant and tangent. This sum is very annoying to me. How do I know the x and y coordinate? Okay, everything goes back to the basic definition. Okay, the basic definition is still here. We know secant is greater than 0. How do we start from here to get the cosine? Can anyone give me a hint? Anyone has any idea?
I mean, wouldn't we just do the 1 over cosine, so it'd be the 1
Very
over a over r.
Great. Thank you so much. Second greater than 0. So what is second? Second is defined here, 1 over cosine. So in other words, is 1 over cosine theta greater than 0. And 1 is always greater than 0. So this fraction is greater than 0 means the cosine theta must greater than 0. Okay, we get this point already. How about tangent theta? Tangent theta is given here. And it seems annoying to me that tangent theta is not written directly by sine and cosine. So we can write just one more step. Tangent theta is b over a, which is also b over r over a over r, right? The r in the bottom part can cancel each other. So this guy in turn to be sine theta over cosine theta. Just a little bit of algebra here. Any question on this algebra? Okay. So now we are told that tangent theta is greater than 0, which means this fraction is greater than 0. So sine theta over cosine theta smaller than 0. Sorry, I apologize. I said smaller than 0. And we know the bottom part is greater than 0. So the upper part must be smaller than 0. So which means sine theta must smaller than 0. Okay. Again, we figure out sine theta is smaller than 0, cosine theta is greater than 0. So this means, by the same reasoning as we did here, sine theta, it depends on the y coordinate. Sorry, sine theta depends on the y coordinate. And our y coordinate is b. Sine theta depends on the y coordinate, so b is smaller than 0. Cosine theta depends on the x coordinate. Since it was defined as a over r, and the only thing matters is really a. A is the x coordinate. So which implies a greater than 0. X coordinate greater than 0, y coordinate smaller than 0. Does that sound familiar to you guys? Look, still give us the same answer. A greater than 0, b smaller than 0. A greater than 0, b smaller than 0. So it must fall into the fourth quadrant again by the same reasoning. Okay, any questions so far? So for this question, we just extend it to the second and tangent. We played a little bit of algebra to figure out the sine cosine. Once we figure out the sine cosine, we know sine theta corresponds to the y coordinate, cosine corresponding to the x coordinate. So we can just determine where the angle is based on x and y coordinate of a point on the terminal side. Okay, that's the basic reasoning of this question. Any question before we turn to the next page? The author of these lecture notes is very considerate. He created an easy way to memorize the signs of those trigonometric functions. Here is a so-called nice quick trick. All students take calculus. Okay, this is all the code you need to memorize the sign. For the first quadrant, all student, denoted by A here, means all trigonometric functions are positive. Let me write down. Let's say just all trigs are greater than 0. Okay, I just write trigs in short instead of trigonometric functions. This is what happens in the first quadrant. When you move to this side, S means sine, okay? Means sine theta still greater than 0. If we have sine theta greater than 0, 1 over sine theta, 1 over sine theta is cosecant, is obviously greater than 0 again, okay? So is cosecant theta greater than 0 because it is 1 over sine. Erase this part, please. This is what happened in the second quadrant. Going to the third quadrant, T. What does that T mean? T means tangent theta is greater than 0. And if you have tangent theta greater than 0, again, by the original definition, 1 over cotangent theta, 1 over tangent theta, which is cotangent theta, is also greater than 0. That's it. And I forget to say that, how about C? C means what? C means cosine theta greater than 0, right? How about the other one? If we have cosine theta, how about 1 over cosine theta? It's also greater than 0, right? So second theta is greater than 0. Okay, so now we figure out those stuff. How about all others which is not listed, which is listed here but not listed here? Here we mentioned sine and cosecant. We didn't talk about cosine. We didn't talk about tangent. We didn't talk about cotangent. How about those guys? All others are negative. Okay. So once you know ASTC, all students take calculus. Once you know this fact, all others are negative. Okay. Any question on this trick way to memorize it?
I have a quick question.
Yes, please.
So for S, then, if sine is greater than 0, then cosine, or not cosine, sorry.
Cosecant.
Yeah, is also greater than 0?
Yes.
Okay, cool.
This was because how we define cosecant. Cosecant is defined as 1 over sine. Okay. So this guy is greater than 0. You see 1 is always greater than 0, so the fraction is greater than 0. So cosecant must be greater than 0. Okay, this is the reasoning behind it.
Okay, thank you.
Thank you for asking. Okay, anyone has any more question? Okay, we done 3 main points of the class already. So we only have the last job to do today is find the reference angle of an angle. What is a reference angle? The lecture note says the acute angle formed by the terminal side of theta and the x-axis is called a reference angle. So let me give you some picture idea. Okay, imagine you have an angle here. This angle and the x-axis together, they form this angle, right? This is an acute angle, okay? So this angle, the reference angle is just itself. The reference for this angle is just self. However, things are not always so easy. So when you increase the degree, imagine you have a much wider angle here. So what is the reference angle for this much wider one? Again, it depends on, look at my hand. Imagine this is the x-axis, this is the angle you have. So it depends on this angle, which is the two sides created, okay? So in this case, if you have much wider angle, the reference angle is here, okay? Similarly, whatever you have, if you have an angle like this, the reference angle is still created this and the x-axis. Okay. Any question on this reference angle stuff? Okay. So don't be shy. Let's just continue to an example. The angle is 330 degrees. What is the reference angle? Okay, so 330 is a very big number. So let's break it into something we can understand easily. How about 330? 330 is 360 minus 30, okay? So look at my pen. If I ask to rotate 360 degrees, what will you do? You start to rotate, you make 180, that's not enough. Then you rotate again, make another 180, you made 360. What is 360? 360, you go back to the origin, right? You went from here, change, then move back, go back to here. So 360 goes back to itself, and 330 is 360 minus 30. So which means if you have done 360 already, you should travel back another 60 degree, 30 degree. So which means you go back a little bit, made another 30 degree here, okay? Negative sign indicating you must go the reverse way. How far do we go reverse way? 30 degree. So what is the reference angle here? So it is this new angle and the acute angle created by adjusting to the x-axis, which is 30 degree. Okay. Any question?
this may be a little bit further down, when we go through with it. But what happens if the angle is at like 270?
Very good question. So let's do it right now. What happens is 270. 270. By the way, everybody is welcome to say some of his or her own angle. This gentleman just said 270. You can consider 250, 210, or whatever angle you want. I will do it for you. 270 sounds a little bit. Sounds a little bit weird. What is 270? It's 360 minus 90. Okay. What does that mean? Similarly, you start your travel, make 180, and make another 360. Once you get here, you should go back. Go back another 90. So go back another 90, you get here. So you pretty much get another vertical angle here. So in this case, our reference angle is no longer an acute angle. You can just say it's a right angle, or you can say the reference angle is a 90 degree. Okay, it's no longer an acute angle because this is a special case, so you can just denote it as a 90 degree. That will be okay. Okay.
Okay, thank you.
Thank you for asking. Okay, so let's continue. What if we have another angle? Theta is 9 pi over 4. What is the reference angle? We do exactly the same thing. Notice that 9 pi over 4 is 2 pi plus a quarter pi. 2 pi is just 360 degrees, we travel to go back to itself. And plus what quarter pi means after we done such a circle, we go a little bit a quarter pi. Okay, go a quarter pi. So a quarter pi is here. That's it. So the reference angle is a quarter pi. Let me write down this. That's it. Any question? When we do this, we notice that we are traveling so far ahead of 2 pi or 360 degree. Whenever we make a whole circle, we go back. Whenever we make a whole circle, we go back. Okay. So although we are increasing the angle 1 by 1, each time we increase the angle by 2 pi or 360 degrees, if we will continue rotating. However, we always go back to the same terminal side, right? The same terminal side. So to put in a picture, if you rotate this angle, rotate it for make one circle, this goes back to this side, okay? But you can continue rotating it. you can continue rotating. It always goes back to the same terminal side again, even though you are increasing your angle, right? So this gives us an introduction about the definition of coterminal angles. Two angles in the standard position is said to be coterminal if they have the same initial and terminal side. In other words, no matter how many times you rotate it, you always reach the same terminal side, okay? So the initial and the terminal side always equal, no matter how many times you add 2 pi or 360 degrees. All the angles here are coterminal. Let's say if we have this angle as 4 pi, so 4 pi over 2 plus 2 pi, you make another extra circle. It goes back to itself, right? So 4 pi, 2 pi, they are coterminal. You can continue a rotating process, make the angle bigger. You add another 2 pi to it. Which is pi over 4 plus 4 pi, which is, I don't know, it's a very big number. I think it's 17 pi over 4. It's still the same terminal side, right? But the angle is just getting bigger and bigger since you're making you're rotating it more and more times. Okay, so all of them are coterminal. This is the idea. Any question on the idea of coterminal angles? Okay. Let's work on an example provided here. What if the theta is 150 degree? What is a coterminal angle? First, find where 150 is. We actually did this 150 degree before. $150 is 180 minus 30. In other words, if you make a 180 degree rotation, you get here, but you should also minus 30 degree, which means you should go back another 30 degree. So I expect you should get something here. Okay. So from this angle, you can rotate another 2 pi, another 360 degree, or more and more. So how about we just rotate another 360 degree? So 150 degree plus 360 is 510 degree. That's a coterminal angle, which is still in the same shape, but just rotate another 360 degree more.
Could you also do would negative 210 also work? Because it still gets you to the same point?
Very good question. So thank you very much for your idea. Look at what I done here. I always rotating counterclockwise. Okay, I always rotating counterclockwise. Just look at my pen, counterclockwise. However, if you want, you can also do clockwise. Clockwise. So 150, if you rotate it clockwise, which means you decrease another 360 degree. Okay, got a negative 210. If you decrease another 60 degree, also goes back to the same terminal. Okay, the reverse way also works. For this question, The question wants us to find a coterminal angles. You can rotate it so many times to create any number of angles you want. However, finding one is enough. If you want to find a positive one, here is a positive one here, giving that you rotate it counterclockwise. If you want to find a negative one, here is a negative one here, giving that you rotate it clockwise. Okay. Any question on this one?
Does it have to share the same angle, or could it just be on the same quadrant?
Well, notice that each time you rotate 360 degree. So 360 degree, you goes back to itself exactly, goes back to itself exactly. So they must be in the same quadrant. Okay, it always goes back to itself. So it's always on the same quadrant. Did I answer your question, by the way?
I think so.
Okay. Don't worry. Feel free to ask me more questions. Okay. Okay. In the other way, in other words, 360 degree, you make a complete circle, complete loop, starting from itself, goes back to itself. Okay. I hope this is the other way which can help you understand. I know.
Okay. So like if you were to have like 151 or 149, would those also be coterminal, or does it have to exactly match up with the 150?
They have to exactly match. 150
okay.
is different from 149. Okay, you have to rotate 1 degree to get one of the other, right? You have rotated. Let's say if you were given with 150, you should minus 1 degree to get 149, right? That's you just move a little bit, okay? But even though you move a little bit, the terminal side has already changed. Just look at my pen. Even though you move a little bit, the terminal side has already changed. So they are not coterminal. However, if you rotate 360, it goes back to itself. The terminal side is still the same.
Okay, thank you. I just wasn't sure if I understood what terminal initial meant. Thank you.
Well, thank you for asking. Feel free to ask me more questions. We have plenty of time during this class. Everybody can ask whatever questions they want. Okay, what if you have 420? Using the coterminal angle to find cosine 20. Cosine 420. I wrote down these hints already. If you are not sure how to find cosine 420, which is such a large number, let's go back to the definition trick. And I will explain how the coterminal side help you to figure it out. So cosine theta, what is cosine theta? It depends on A, which is the x coordinate. It also depends on R, which is the side, the length of the hypotenuse. If you rotate to make a complete circle, okay, this is what we did before. If you rotate and make a complete circle, x, y does not change. Okay. In other words, all coterminal angles shares the same x, y coordinates. Okay. Just look at this point. If you rotate it 360 degrees, it goes back to itself, right? It goes back to itself, no matter how many times you rotate it. As long as it is 360 or 720 or minus 360, a number which is a multiple times of 360, it still goes back to itself, right? So they share the same xy coordinate. By the definition of cosine, as long as they share the same x and y coordinate, the cosine value does not change, right? Because x does not change, hypotenuse does not change. So let's break down 420 to see how can rotate it back to a small angle, which we know already. 420 is 360 plus 60, right? So if you rotate 360 back, if you rotate 360 counterclockwise, you went back to 60. So in other words, 420 cosine equal to cosine 60. Any question on this one? Okay, and we did it so many times before. Cosine 60 is just 1/2. Any question how we get from here to here? Okay, cool. It seems that we're going to finish our class earlier. Okay, so this is our last question in today's class. It's going to be a big question. It has 4 steps. The question wants us to find the exact value of the remaining 5 trigonometric functions given sine theta. And you were told that this theta is in the second quadrant, okay? So how do we find other sides? Step 1, we know theta is between 90 degrees and 180. So it means it is if you rotate the angle, you should get somewhere here. This is 90, this is 180, so it's definitely somewhere here. With step 1 done, then identify given sides. What does that mean? It means we should fabricate a point on the terminal side and create triangles. I'm showing how I fabricate it. Sine theta is 5/13. Okay. Again, by the definition of sine theta is B/R. So how about I just fabricate R is 13, B is 5. So just set B equal to 5, R equal to 13, okay? That's what I mean by saying fabricate. What do you have? Okay, let me draw another graph. If you make this side 13, B is 5, B is the y coordinate. So which means this side is 5. And since this is a vertical line, you need to figure out this side. And that's the only side which needs to be figured out, right? Okay, we just fabricated such a point here. How do we figure out this side? Can anyone provide any idea to me? How do you figure out this side?
You can use the Pythagorean theorem again.
Yes, please. Great. So we don't know what this side is. How about we just denote A? And using the Pythagorean theorem, we know A squared plus B squared. B is 5 already, equal to 13 squared. Instead, B squared plus 25 is 169. A squared equal to 169 minus 25 is 144. Okay, 144. I did this so many times. I know you guys may not have done as many times as I did. If you take a square root of 144, you should get 12. So 144 is 12 squared. Okay, just to let you know. You can use a calculator to find out, or you can do it by hand. So A is 12. Okay. Great. We find A is 12. And we know sine theta is this value. So how about the sine of the other angles? Remember, all students must take calculus principle. All students take calculus. All students take calculus. Here it means sine is positive, and one over sine, which is cosecant, is positive, and all other trig functions are negative. Sine theta is positive, cosecant theta, my bad, is positive, all others negative. Okay, so let's use this reference angle. This is a reference angle created by such a wide angle to figure out what is cosine. What is cosine theta? Cosine theta is the adjacent side divided by hypotenuse, right? However, how about the sine? This is negative, okay? Sine cosecant greater than 0. So, but the sine is negative, so okay, don't forget the negative sign. So 12 over 13. If you figure out the cosine theta, secant theta is just a piece of cake. It's 1 over cosine theta, which is 13 over 12. Tangent theta is this divided by this, right? However, the sign must be negative. All others negative. So it is negative 5 over 12. What about cotangent theta? cotangent theta is this side divided by the opposite side. 12/5, and don't forget that all signs are negative. Okay, so we are done with the 5 quadratic trigonometric functions already. So the only thing we need to figure out is sine theta. Sine theta is given already, negative, positive 5/30. So you should figure out cosecant theta, which is 1/sine. So it's 13/5. Okay, that's it. So anyone has any question how we figure out those values?
Yeah, why was 12/13 negative?
12/13. Well,
Sine theta?
we're talking about this one, right?
Yeah.
Okay, great question. So remember we have the all students take calculus principle. So S means sine. It means sine is positive and cosecant is positive, but all others trigonometric are negative.
Okay.
Okay, that's why we have a negative sign here.
Okay, that makes sense.
Okay, thank you for asking. Anyone? Yes.
So if it didn't specify that angle theta was greater than 90, would the point have been in quadrant 1? Or
Well,
because it's sine
it really
theta? Sorry.
so almost always the author of the question will tell you enough information to determine which quadrant it is. Here it tells us the information it is in the second quadrant. Okay, if he didn't tell you this information, he will tell you some other information that indicating which quadrant it is.
Okay, gotcha.
Okay. Thank
Thank
you
you.
for asking, Cody. By the way, I like your background picture. This
Thanks.
looks very Colorado. Very, very Colorado. Okay. Okay. So we reached the end of the class, but please do not go. I need to take attendance of you right now and still stay here until 9:15. Feel free to ask me any question. Okay, let me take attendance. Okay, feel free to ask me any question.
Could you possibly show your first page of notes?
My pleasure.
Thank
By
you.
the way, I will make a photocopy of it and upload in the Canvas every time after class. Okay, just to let you aware. If you missed anything from notes you didn't copy, don't worry. Those things will be scanned and uploaded. Hi, is this good enough for you?
Yes, that's perfect. Thank you.
You're welcome. Don't forget that we have a project due on this week. So we have a project. Don't forget about that.
Hey, Professor, I have a quick question on my
Yes,
math.
please.
It says something about a prerequisite that we had to get like 80% on it. Is that a requirement or?
So the
it
prerequisite is a requirement. It's a requirement set up by the system. So it means you must have enough knowledge to take this class. Otherwise, you have to do more review to get yourself prepared so that you can proceed into this class. Did I
have
answer
a
your question? Hello? Did I answer your question?
Yes, I did. Thank you.
Yes, please.
I have a question.
Yes, please.
Can you go over like second question in reference angle of 9/4?
Second question, which one?
Reference angle.
Second page?
Yes.
Which
Second
one?
question. 9/4 page.
9/4. Yes, this one.
Yes.
Okay. Here, the question wants us to know the idea of the reference angle. Reference angle is just the acute angle formed by the terminal side. Okay. So 9/4 pi is a large angle. We can break into it into a small angle, 2 pi plus 1/4 pi. So I know you guys should know that if we rotate 2 pi, it goes back to itself, right?
360. Yeah.
So you rotate 2 pi, it goes back to self. Then you rotate another 1/4 pi. That's it. So the reference angle is just your last 1/4 pi. Okay. Did I answer your question?
Yes. Yes, you did. Thank you.
Okay, great. Thank you for asking. Feel free to ask me more questions. Okay, we reached the end of the class. Stay here if you have any question. Otherwise, feel free to go.
Thank you.
Goodbye.
Thank you.
Have a nice day.
You too.
I have a question.
Yes, please.
Do you have an office hour for tomorrow? Because I'll miss 7.5 section.
I only have office hour at Tuesday, Friday. It's in the syllabus. But if you
Oh,
have any question, feel free to ask me right now.
yeah, because I would like to go to over 7.5, which
I'm sorry. What did you say?
I want to go over on 7.5 section.
7.5.
Yeah, you
So-
say over Friday, right? Tuesday.
Can we talk right now?
Do you have a time?
Yes, I have time.
Okay.
Yeah. So 7.5. Okay, I think. Let me find the worksheet. Okay. Which question do you have?
Our first question.
First question. Yes. So can you please give me more hints on what question you have on the first one?
So it said here, like, a square plus b square equals c square. And then
Oh, yeah.
3 square minus 4 square. How we can find out the c square, because I've missed class that day.
Okay. So let me show my document camera. Okay, this is my document camera. This is what we talked today, but there's same thing with the 7.5. Okay?
Okay.
Jose?
Yes.
Yeah. So for that question, you were told with A and B, the X and Y coordinate already, right? Right?
Okay.
So let me show you. For that question, what is A? A is 3, B is -4, right? And you were also told that the x squared, which is also a squared plus y squared equal to r, so which implies 3 squared plus 4 squared equal to r squared. 3 squared is 9, 4 squared is 16, which is 25. 25 is r squared, which implies r is 5. Agree?
Yes.
Cool.
Okay.
Once you get here, everything pretty much follows the same
Oh, I see.
calculation here. Sin theta is b over r. B is this guy. R is this guy. Cosine theta is a over r. A is this guy. R is this guy. That's it. So you just put all the numbers like this. We did it today. What we did today. Okay.
Okay.
Hossein,
Yeah,
did
yeah,
I
I
answer
got
your
it. I think I got it. Yeah.
Okay, did I answer your question?
Yes. Thank you very much.
Okay, cool. Do you have other questions?
Mm. Yeah, the last question. What does sec of 7 over 3 pi?
Last question.
Yeah.
Oh, well, which work? I'm sorry,
7.5
which
last.
worksheet are you talking about?
7.5.
7.5 last question. Sorry, which question are you referring to?
One of them it said, what does secant 7 over 3 pi?
7 over 3, 5. Oh, it's here? Are you talking? So second 7 pi over 3, right?
Yes.
Okay, cool. Let's work on it. So look at on the worksheet, you have the periodic properties, right?
Mhm.
It means if you rotate the angle every time you rotate 2 pi, it goes back to itself. In other words, you see 7 pi over 3 is 2 pi plus a third pi. Do you agree? Hossein? Do you agree with this? Look at my writing.
Yeah, I just want to ask like how you guys get in that 2 pi over 1 over 3.
Very good question. So
Okay.
7 pi, it is 6 pi plus pi over 3. Do you agree?
Yes. Yeah.
So you split
Yeah.
them into 2. So this is 6 pi over 3 plus pi over 3. Do you agree?
Yes. Got it.
So it's 2 pi plus pi over 3.
Yes.
6 pi over 3 is 2 pi. Okay,
Yes. I got it.
cool.
Yeah.
So second 7 pi over 3 is just second 1/3 pi because it goes back to itself. Okay.
Mhm.
And the second 1/3 pi is just 1 over cosine 1/3 of pi. Okay, by the definition of a second function.
Yes.
Do you agree? So cosine 1/3 pi is just 1/2. So it's 1 over 1/2, which is 2.
Yes. I got it.
Okay, cool. Any
Right,
question?
Thank you very much.
Anything else I can help you?
That only. Thank you so much.
Okay, you're most welcome. Feel free to ask more questions in the future.
All right. Have a good day.
Okay, have a good day.
Thanks.
Hello, Rebecca, Nino, Sophia, do you have any question for me?
Yeah, I do. I was wondering if I could ask about the application project. I just have a couple questions on it.
Yes, you can. But I assume your question may be longer than theirs. Let me check if they have
Okay.
shorter questions. Hi, Rebecca, Nino, do you have any question for me? Rebecca, Nino, are you there? Okay, Sophia, let's go ahead. Seems that they are not here.
Okay, so for part 2,
Hi, Sophia. I would recommend you to share the screen so that I can know what you are talking about.
oh, I don't, I have it written down on like a piece of paper. I don't have it like on my screen, I guess, but I can, let me see if I can figure it out. This might take a second. Okay. I think you have to enable for me to share screen.
Yes, my pleasure. You are allowed already.
Okay. So I guess I want to make sure I got the answers for these two right, and then maybe ask how to do this as well. So for 2a, which is this one here, I got the square root of 100 minus h squared, but I'm not sure if that's correct.
So let me think about it. Can you scroll up your notes a little bit? Scroll up. Okay. Scroll back to the question, please. Let me see it. Okay. So here you are just giving these letters, unknown letters. You're not giving with the radius already. So you see the radius is bottom side, right?
Yeah.
So sine theta is r/10. Do you agree?
Yes.
Sine theta, which is opposite side divided by the hypotenuse, is r/10.
Yeah.
Okay, let me write down on the paper. Okay, please look at my screen, my writing. Sine theta is r/10. Okay. So you have to figure out what is r. You just multiply both sides with 10. So it's 10 times sine theta. That's it.
Okay. So it should be more like according to the angle that we have to find, which the angle is kind of like you're given the angle and you have to find
Yeah.
the radius. Okay. How would you do the height then? Or h?
Height.
Yeah.
So look at the triangle you have. So this is theta. So cosine theta is the height. Is denoted by h/10. Do you agree?
Yes.
So you multiply both sides with 10. H is 10 times cosine theta. That's it.
Okay. And then for finding the volume, I'm not sure how to apply those two things to finding the volume.
Okay.
For like the
Okay.
equation.
So let me share my screen. So please look at the part 1C. The formula for the volume is given there. Part 1C.
Yeah.
V is 1/3 pi r squared h, right?
Yes.
So r is given here, h is given here. You just plug in.
Oh, okay.
Okay,
So
that's it. Do not overthink about it.
Okay, perfect.
Anything else I can help you?
I think that's it for now.
Okay, great. Thank you for asking.
Thank you so much. Have a great day.
Oh, you're welcome. Have a good day. Hey, Rebecca.
Ready? Front sit. Sit. Catch. Good girl. Good catch. Drop it. Drop it. Good girl. Okay, catch. Sit. Catch. Good girl. Good catch. Drop it. Drop it. Drop it. Sit. Sit.
Hello, Rebecca. Hello, Rebecca.
Hello.
Yes, do you have any question for me?
Oh no, sorry, I was in the restroom.
I'm sorry, do you have any question for me?
Oh no, I was in the restroom, so that's why I forget to sing out.
Okay, that's fine. Have a good day.
Okay, thank you.
Bye. Hey, Christine, do you have a pen like this?
We do.
You do already.
Well, it's not electric. It goes over the stove, the gas stove. But it's a griddle like that.
Would you like to have additional lecture?
Sure. We'll have gas here.
Cool.
We're generally kind of minimalist.
Gotcha,
But,
gotcha.
Maybe we'll ask Peter. I think
No problem. I just
we're probably okay with the gas one.
Yeah, I think I've done it.